Yeah, it was sort of.
5 foot 4.5 down to 5 3.5.
Well, there you go. Contraction. So anyway, we've been looking at these decimals. We talked about the operations with decimals last week. Today I want to talk a little bit about dealing with powers and multiples of 10. If we have 38 times 10, pretty simple multiplication. What does that come out to be? 380, right? The 10 just adds a 0 onto the end of it. So if we have 38 times 10,000, of course, it's going to be... Perfect. You count the zeros. 1, 2, 3, 4. You put 4 zeros on the end of it. So 380,000. So as long as this is a 1 here, it's a simple multiplication. Well, what if it's not a whole number like 38? What if it's like 4.73 times 1,000? Now you can't just count the zeros, though, and put the zeros on the end of the number. Okay, you count the zeros. There's 3 zeros. And that's, instead of just adding zeros to the end, the number of zeros is telling you to move the decimal point. What we were really doing here when we counted 4 zeros was we were moving this decimal point 4 spots to the right. But since there were no numbers there, we had to fill in those 4 zeros to occupy those spots. So 4.73 times 1,000, since there are 3 zeros there, is telling us that that decimal point has to move 3 spots to the right. So 1, 2. Now we do have to add in a 0 to go to the third spot. So that's 4,730. What if it's not a 1 at the beginning of that, though? What if it is something like 42 times 200? Perfect. We can just do the 42 times 2, which is 84, and then move the decimal point. 2 zeros means we move it 2 spots. 1, 2, 8,400. Or we might have, I should be careful how I do this. .14 times 30,000. Well, we can do the 3.14 times 3, which is going to give us what? 12, carry the 1, 3, 4, decimal point, and 9. 9.42. But then we have the 4 zeros tells us to move that decimal point 4 spots. 1, 2, add a 0, 3, and another 0 is 4. So 94,200. Not so bad. The opposite is true then when we divide. Let's say I have 480 divided by 100. When we divide, we're moving the decimal point the other direction. So there's 2 zeros. Decimal point has to move 2 spots. 1, 2 makes 4.8. Now, we've been taught before that if you have something like 240,000 divided by 100, that you cancel out the zeros, right? Well, again, what all it really is that 100 has the 2 zeros. It means we move the decimal point 2 spots. So, yeah, it does cancel out 2 zeros. But it's really moving the decimal point that makes the zeros go away. Just like with the multiplication, it doesn't have to start with a 1. We could have 48,000 divided by 300. So the same thing. What is 48 divided by 3? 16. And then the 2 zeros means you got to go 1, 2. No, there. Technically, the way I would do it, or the way you really should do it, is you got the 48,000 divided by 3. So you got 16. You leave the 3 zeros on it to get 16,000. Then you would work with these 2 zeros to move the decimal point over 2 spots to get 160. So let's say we have 8,100 divided by Let's do 30. So we start out by doing 81 divided by 3 is 27. So we got the 2 zeros there yet. Now we got to do this 0, move the decimal point over 1, 270. Now this is just something I'm throwing out there, not because it's something you're going to have to do a lot. I'm throwing it out there because when you're using your calculators, you should be thinking about this in the back of your mind. I don't care so much that you can look at 8100 divided by 30 and get 270 as your answer. But what I am concerned with is you look at that and say, okay, I'm expecting somewhere around 200 or 300. Because when you punch this in your calculator, is that the right answer? What did I do wrong? I put an extra 0 in there. That's not 8100. I typed in 81,000. Now, usually you leave out a 0, but you can see my point. A lot of times you make a mistake hitting an extra key or thinking you pressed the key and it didn't register. You have to have that estimation like this. Again, not necessarily getting the exact 270, but having enough of an estimation of that answer before you type it in to know whether it's going to be wrong or not. So when we do our decimals, we talked about multiplying and dividing decimals last Wednesday. If I have, what do I put in here? So something like this, 4.8 times 3.2. Is that the right answer? Well, here, because my calculator displays the problem, I can very quickly see, yeah, I put in 32 instead of 3.2. But if you have one of the cheaper calculators that don't have the second line display, you don't see that. As I've stressed before, when you're typing these in, 4.8 is about what? About 5, right? 3.2 is about 3 or 4. 5 times 3 is 15. Before you punch these, and you don't have to write it down, but just look at it. 4 and 3 is 12 or 15. Make sure you have that in your head before you punch it in. 153 is not a reasonable answer no matter how you look at that as an estimate. But I see it all the time. People punch in their calculator, that decimal point doesn't register, they don't catch it, they write it down, they make a stupid mistake. Multiplying isn't nearly as bad as dividing. I see it a lot when we divide. Let's say we have, especially with the decimals, because of the way the decimals interact, you get some answers that maybe you wouldn't expect so much. Like 4.83 divided by 0.3. Well, the biggest thing when you're dealing with a problem like this, you're dividing by something smaller than 1. So what does that mean about your answer? Well, let's step back. If you did 4.83 divided by 1, what do you expect your answer to be? Divide by 1, anything, you get the same thing, right? You don't change it. 4.83 divided by 1 is 4.83. Make sense? If you divide by something larger than 1, if you divide 4.83 by 2, do you expect the answer to be bigger than or smaller than what you started with? Smaller. 0.415 is what you end up getting there. So back here, you're dividing by 0.3. You're dividing by something smaller than 1. You expect the answer to get bigger. Well, yeah, if you were dividing out by hand, you would move the decimal point. This is 1 decimal place in it, so you're going to move it 1, which means you move this one 1. So it becomes 48.3 divided by 3. So you're going to get 16.1. Right? If you were doing it by hand, that's how you do it. But if you're punching it into the calculator, you're not necessarily moving the decimal points. That is one way to estimate it. That's actually how I estimate it. Is I move the decimal points and look at, okay, yeah, 4.83 divided by 0.3, that's 48 divided by 3 is 16. So when I punch it in the calculator, I know Well, I better get something close to 16. The calculator gives me 16.1. The other way of looking at this is, what would I have to multiply this by to make it close to 1? Like times 3, right? Make it close to 1. I might be confusing you here with some of the estimating. If I multiply 5 by, what's that? Yeah, well, 0.3 times 3 is like 0.9. That's close to 1. So if I take 5 times 3, I'm getting an answer close to 15. 16 is close to that. $1.61, is that the right answer? Makes sense. We're dividing when our brain locks into when we divide, things get smaller. For most of us, we would type that in, get 1.61. Sounds good. What did I do wrong? It's 0.3. So it's 16.1 is what we're looking for there. All I'm saying is when you're doing operations with these decimals, it's even more important that you have that estimate in your head. Because on most calculators, the decimal point is one of the first keys to start to malfunction. I don't know why, but a lot of statistics have been run. It's the decimal point is one of the first ones that starts to get brittle. Basically, it doesn't register when you push it for some reason. So be careful with that. So anyway, we also talked a lot about converting fractions to decimals and the other way around. If I have 0.0125, if I want to convert that into a fraction, what am I going to do? Well, it's 125 over what? Well, it's tenths, hundredths, thousandths, 10,000ths is the last place value. So as the place value of the last digit is what my denominator is going to be. Now remember, we talked about a little trick, by the way. 1, 2, 3, 4 decimal places. 1, 2, 3, 4 zeros in our denominator. Now, of course, we're going to reduce this. What can both of those be divided by? 25. Giving us 5 over 400. Are we done? No, they can both be divided by, both be divided by 5 yet. Giving us 1 over 80. If I want to take a fraction back into a decimal, what did I do? Is this right? Yes, no, not sure. Say no. What's wrong with it? It's always numerator divided by denominator. Should have been 3 divided by 8. 8 divided by 3 is going to give us 2.66666. There's no way 3/8 is bigger than 1. It's smaller than 1. So when I do 3 divided by 8, of course, does 8 go into 3? No. So I have to put a 0 above it, and then I have to add a decimal point. Once I add the decimal point, what can I do? I can add zeros. 8 goes into 30 now 3 times. 3 times 8 is 24, gives us 6. What do? Add another 0 and bring it down. 8 goes into 60. 7 times would be 56. We can keep adding as many zeros as we want to here. Either it'll eventually end or it'll form a pattern. But generally, we have a degree of precision, is the technical term for it. We have a rounding that we want to go to. If we are told that we want this to the nearest 1 billionth, no. Nearest hundredth. Are we done? In the sevens and the hundredths place, we need to go at least one more. Why do we have to go one more digit? Yeah, to tell whether that's going to be a 7 or if it's going to round up to an 8. So we bring down one more 0. Oops, we got to subtract to get 4. We bring down the one more 0. 8 goes into 40. 5 times. Well, this one actually ends at that digit, but that 5 is telling us this rounds up to 0.38 if we're going just to the nearest hundredth. What if we have something like this? (19 5/11), and I want it in a decimal to nearest 1,000. Whenever you guys figure that out for me quick, I'll give you a couple seconds. What do we do with the 19? Answer? Nothing. All we are dividing out, what's our division going to be over here? 5 divided by 11. Good. Does 11 go into 5? No, so put a 0 there. Now that 0 is going to be replaced with the 19 when we're all done here. But anyway, put a 0 above the 5, we add our decimal point, and now we can add a 0. Does 11 go into 50? Yeah, 4 times. 4 times 11 is 44. We subtract to get 6. Add another 0 and bring it down. 11 go into 60? That would be 5 times. 5 times 11 is 55. We subtract to get 5. Are we done? No. Add another 0. That's 50. 11 goes into 50. 4 times. 4 times 11 is 44. We subtract to get 6. Now at this point we might notice something happening. What do we notice? This one's going to repeat. This is going to be 0.454545 repeating. Do we want to write it as 0.45 repeating like that? Of course we'd have to put the 19 in front of it, so 19.45 repeating. Exactly. This says to the nearest thousandth. It doesn't say find it exactly. If it said find it exactly, we would want to do this. But this says to the nearest thousandth, which means we're going to write it to the thousandth. We're to the thousandth here. Do we stop? One more 0. 11 goes into 60. 5 times would be 55. We had to go that one more place because now this is going to round. So 19 goes in front of the decimal point. It'll be 0.455. So even though we see that repeating pattern and we find a repeating decimal, because it says to the nearest thousandth, we are going to write it out and round it to the thousandths place. Other things we're going to use with our decimals. Well, we might have some nice little equation like this. Oh, what do I put in here? What do we do with something like this? Add 8.1. Perfect. So we got 2.1x equals 18.9. And then we're going to divide by 2.1. Okay, so x equals 9. Good. Questions? So just like with any other equation, x has been multiplied by 2.1 and then 8.1 has been subtracted from it. So to solve it, we add the 8.1, gets rid of it here. Adding 8.1 over here gives us 18.9. And then we have to divide by the 2.1 to get rid of it. Let's do another example. Need a second to get that one down? Okay. So tell me what to do here. Subtract 7.2. So 1.4x equals 7.6. Okay, and then what? Divide by 1.4. Okay, so we get x equals what? 5.4285714 approximately. Yeah.
If it did ask for anything different, I would automatically make it 5.4.
Okay. So that's the question: is what would you enter into MyMathLab?
Would that matter?
Well, MyMathLab will always specify, go to the nearest hundredth or to the nearest thousandth or something like that. If it does not specify that, MyMathLab is then actually probably asking for a fraction. Now, since this is all given in decimals, I would almost guarantee you MyMathLab is going to be asking you to round it to a certain decimal place. But what if it didn't? What if it did want this to a fraction in this case? How would you do that? Well, we got 7.6 divided by 1.4. I purposely write it that way because it looks like a fraction. And we've discussed this a few times. A division problem and a fraction are interchangeable. So 7.6 divided by 1.4 can be treated as 7.6 over 1.4. Now, we don't like decimals in our fractions. How do we get rid of them? Well, each of those numbers has one decimal place in it. If we multiply by 10, it would get rid of the decimal in both of them, wouldn't it? This would become 76 over 14. Now we can go ahead and reduce that. Of course, both of those can be divided by 2. I would do that probably. Giving me 38 over 7. Then 38 sevenths I can reduce into a mixed number. 7 goes into 38 how many times? 5 with 3 left over. So 5 and 3 sevenths. It does now it's starting to take mixed numbers now. For a long time there it wanted it as improper fractions. But, yeah. For a long time though it wanted it as improper fractions, and in the last couple of assignments it will accept mixed numbers now. I know it's weird.
Read the directions and then we'll
Well, it is very picky, unfortunately. On tests, I'm not nearly as picky as MyMathLab is. And on a quiz, if it ever marks one wrong because you put it in as a mixed number instead of an improper fraction, just send me an email and I'll change those grades.
I've tried sending.
It doesn't come through? Really?
I can't get the emails now.
Okay. Well, then just write me a note or something and give it to me in class so I know. If it's not in writing so I can go through and check, by the time I go through and check, I forget which problems I'm supposed to look at. Okay. Well, I mean, you should still get credit for work you do. Okay, so I'm going to have you guys try one. Go ahead and try to solve that one. The nearest hundredth if it has to be rounded. So what's our first step? Add 4.8. Good. So 7.3x equals 24.4. What's next? Divide by 7.3. So x equals 3.34 if you're going to the nearest hundredth, right? Hundredth would be 2 decimal places. Actually, let's do this. So let's take 4.2 times 3.5x minus 2.1 equals 24.6. We have to distribute. What do you mean by that?
Well, you have to take 4.2 times
Perfect. We have to multiply everything in the parentheses by the 4.2. So 4.2 times 3.5x is 14.7x, correct? Then we have to do 4.2 times a negative 2.1, which is negative 8.82, correct? That still equals 24.6. Once we get to that point, what's our next step? Add 8.82. Get rid of that. So this is going to be 33.42 over here. 14.7x equals 33.42. And then what do we do? Divide by 14.7. X equals 33.42 divided by 14.7. 2.27 if we're going to the nearest hundredth again. I didn't specify there, but we'll just keep it to that. That's it. Yep. What am I going to do here? Well, I find my equal sign, and I see that the x appears on both sides of the equation, which means I have to get rid of one of them. Which one am I going to get rid of? 2.4x is the smaller one, so I'm going to get rid of it. It's positive, so I'm going to subtract 2.4x to make it go away. That leaves me with just the 6.5 over here. But if I took 2.4x from one side, of course, I have to take it from the other side. Where do I take it from? The 3.8. So I take 2.4x from 3.8x, which gives me 1.4x. I still have the negative 7.1 there. And then add 7.1, so you got 14, or 1.4x. Add 7.1 here, you get 13.6. And then? So we divide by 1.4. X is going to equal 9.7142857143 approximately.
See, I thought that's something.
Oh yeah, I am just showing off. So X equals 9.71. I gotta have a little fun.
Oh, dang it. We got it exact.
I've done this stuff a few times before. Once or twice. Like 30. Okay, so let's give you guys one to try here. Me be mean? Never.
That looks mean.
Go ahead and try to solve that one. So what's our first step? Okay. You can look at it either way. Either you're adding the 3.2 and a negative 1.1x, or it's 3.2x minus 1.1x. Either way, you get 2.1x. Yeah, minus 4.5 equals 8.4. Okay, we add 4.5 to get 2.1x equals adding 12.9. Okay. So we divide by 2.1, which gives us that x equals of 6.1428571429 approximately.
But it's 6.14.
If we're going to the nearest hundredth, it would be 6.14. Hundredth is 2 decimal places. You keep going that extra place. You would stop here, but that 2 would tell you that you don't have to round up, so it's 6.14. Because remember, it's tenths, hundredths. You need the 2, but the 2 only tells you whether to stay the same or round up. What if I tell you to evaluate 3.7x minus 5.2y when x is 2.1 and y is 1.8? How is that different from what we were doing?
Well, you're plugging in.
I'm not really solving for anything. I'm just putting the numbers in and seeing what it calculates up to.
We cannot find those plugs.
So I put 3.7, it's going to be 3.7 times 2.1 minus 5.2 times 1.8. So 3.7 times 2.1 is 7.77. Minus 5.2 times 1.8 is 9.36. Then we subtract to get a negative 1.59. There we go. You guys doing okay with that process? We've looked at that one before. I just wanted to point out that it was different from solving the equation. Well, let's step up to, of course, their ultimate goal of this class is to be able to do problem solving. So let's look at this. Balls sell for $4.50. And bats for $8.25. If 3 times as many balls as bats are sold, for a total of $652.50. How many of each were sold? There probably wood or something. This sets up just like problems we've done in the past. It's just there's decimals in it, which makes it look more complicated. We're still just looking at bats and balls. And we're going to look at the number sold. To define the number sold, we need our variables. Now, one of them is referenced off of the other. So that's the first thing we have to figure out. Which one is going to be x and which one's going to be something times or something plus or whatever to that x. Well, there's 3 times as many bats as 3 times as many balls as bats. So which one would that tell us we should make x? The bats. Because the balls would be 3 times that, or 3 times x. Now the next thing we need to know then is the money, because we're not told the total number sold, we're told the total dollar amount. So we need to convert that into dollars. The dollars for bats would be x times the cost per bat. So $8.25 times x is the amount of money from the bats. The money from the balls would be the cost of $4.50 times 3x, or 13.5x. And we know that those two are going to have to add up to 8.25x plus 13.5x has to add up to $652.50. From there, what do we do? So yes, 8.25 and 13.5 make 21.75x equals 652.50. And then we divide 652.50 divided by 21.75. 30. X equals 30. So we're all done? All right. X equals 30. That's the number of bats. There are 30 bats. The number of balls sold are 3 times 30, or 90 balls. What do you think? Ready to do those on your own? There's a new quiz due Tuesday at 11:59 p.m. and new homework due Wednesday.
And we have whole.
Is homework due yet today? Yep.